And our last section is 9.6, looking at parallel and perpendicular lines. So I know we've actually already mentioned these two concepts, so let's see if we remember how this works. So two lines that are parallel have the same slope and different y-intercepts, because remember, parallel lines are two lines that go on but never cross. So I mean, just a little example. Let me do this instead. I'd have to have the same slope, right, and different y-intercepts in order for those lines not to cross. And then we talked about perpendicular lines. Remember, those are lines that meet at a right or a 90-degree angle. And in order for that to be true, their slopes had to be negative reciprocals. So, just a rough sketch again. Oh, I don't know. Something like that, right? You have a right angle here where the lines meet. So the first question is, are the lines parallel, perpendicular, or neither? So what we have to do is we have to look at the slopes. So for line 1 here, the slope is 3, right? So that's 3 over 1. In line 2, I may want to rewrite, because that negative x over 3 is the same as negative a third times x, right? So the slope of that line is negative a third. So I'm looking at two things, really. I'm saying, are the slopes the same? No. Are the slopes negative reciprocals? Yes, because if I take 3, what I do is I flip that, that's the reciprocal. Then I make it negative, and that's indeed slope number 2. So should I call that one M2, this one M1? So what would I conclude? I would conclude these lines are perpendicular. Okay, I mean, do I need to graph them? I don't know. I guess we can graph. I don't want to graph all of these. I guess we can graph a couple of them just to demonstrate. Okay, so line 1, let's see. The y-intercept is negative 1. The slope is 3. Up 3, right 1. Up 3, right 1. So that's the first line. It's the y equals 3x minus 1. The second line, let's see, the y-intercept is 6. The slope is negative a third. So down 1, right 3. Down 1, right 3, etc. Okay. So that's negative a third x plus 6. So these guys, see how they meet at a 90-degree angle there. So second set. So before I can determine if the lines are parallel or perpendicular, I'm going to have to solve for y, because I need to put these in slope-intercept form. Okay. So I've got x minus 4y equals 24. Subtract the x. Divide by negative 4. So what do we end up with for the first line? Let's see, -1 over -4 is a quarter x. 24 divided by -4 is -6. There's line 1, written in slope-intercept form. I'm going to need more room. Let's move that down. So then let's look at line 2. So for line 2, solve for y. Okay, so let's subtract the 2x. And divide by -8. So let's see, -2 over -8 is positive a quarter. -8 over -8 is positive 1. There's line 2. Okay, so line 2 and line 1. Okay, now I look at the slopes. So here the slope is a quarter. Here the slope is also a quarter. Okay, I have different y-intercepts, so I would conclude, indeed, these lines are parallel. Okay, so, blah, 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 blah. Do I want to graph them? I guess not. So, I mean, I'll kind of just do a really rough sketch, just thinking, well, I'm not going to graph this to scale. If I look at this guy, the y-intercept is down here, 0, -6. The slope is up 1, right 4, so I don't know, something like that. I'm being really rough with this one. And then the second line, the y-intercept is 1. The slope is up 1, right 4, so something like that, just to see that those are indeed parallel. But I didn't do a nice graph for that one. Okay, one more set. Let's see, let's start with line 1. Divide by -2. So 1/2 x plus 4. Let's look at line 2. Divide by 2. So -1/2 x plus 1. Okay, so my second slope here is -1/2. My first slope is +1/2. So they are not the same. So what could I say? I could say +1/2 is not equal to -1/2. So they're not parallel. What about perpendicular? So for M1, the slope of a perpendicular line would be the negative reciprocal. So it'd be -2. Flip it, make it negative. For M2 here, the slope of a perpendicular line would be -2. Okay, so these guys are not perpendicular either because they're the same fraction, right? It hasn't been flipped. So my conclusion would be these lines then are neither. Okay, so what about an example where we need to find the equation of a line parallel to a given line? So here I'm given the line y equals -5x minus 2. So if I know the line I'm looking for is parallel to this guy, Remember, in order for it to be parallel, that means it has to have the same slope. Okay? So if you look at this guy, the slope is -5. So if I set up my line using point slope form, it's going to look like that, right? So remember, I have to fill in the y1, the m, and the x1. But I'm given this point on my line. Okay, so let me fill in that information. Let's distribute. And add the 6. And so there's my line. So let's see, quick little check. Got the same slope, got a different y-intercept. Find the equation of the line parallel to y equals 3 through 1, -2. So this is a special one because y equals a number, that's a horizontal line, right? So there's y equals 3. So the line I'm interested in, it must also be horizontal, right? That's the only way it's going to be parallel to a horizontal line. So if it's horizontal, it's y equals a number. So the point that I'm interested in is 1, -2. So here's that line. So that's going to have to be y equals -2, isn't it? Another special case, parallel to x equals -1 through 4, -3. So again, parallel to and x equals is a vertical line. Okay, so I know my line is going to be vertical also. So it's going to be x equals a number. So the number is going to be 4. Okay, because the line we're given is this one. There's the point. Okay. Find the equation of the line perpendicular to this guy. Okay, so there's an important difference. So perpendicular means the lines meet at a 90-degree angle, and it means the slopes are negative reciprocals. So for the given line, we'll call that slope 1, it's -2. So that means for the line I'm interested in, I'm going to flip that and I'm going to make it opposite sign. So +1/2. Here's my x1, y1. So I'm going to do my point slope form. Y minus y1 is m times x minus x1. then like so. Distribute and subtract. So y is a half x minus 4. Slope-intercept form. Oh, I don't know. Do we want to do a sketch and check? Okay, so the line we started out with, the y-intercept is 5, the slope is negative 2. Okay, line I was arrived at is y-intercept is negative 4, slope is a half. Okay. So here's our 90-degree angle. Looks pretty good. And here are our special cases. Find the equation of a line perpendicular to y equals negative 2. So y equals negative 2 is horizontal. Okay, the point of interest is negative 1, 2, 3, 4. Okay, perpendicular, remember what that means. They meet at a right angle, 90-degree angle. So the only way that's going to happen is if I have a vertical line here, right? Since this is a special case and I need this to be a 90-degree angle. So a vertical line is of the form x equals a number. So that's going to be x equals negative 1. What about this? This is going to be the opposite, I think. Here's x equals 4. That's a vertical line. Let's see, the point negative 3, 1. And then again, I'm looking for a perpendicular line. So that's going to have to be horizontal. Y equals 1. 90-degree angle. I think there's one more. This is kind of a special one. Plot the points A. Let's see. A, B, and C. I need to move this, I guess. There we go. Okay, A is negative 5, 3. Let's see. B is 6, 0. And C is 5, 5. connect them with a triangle. Okay. Okay, and then what? It says, use slope to decide if the triangle is a right triangle. So the question here is this a right angle? Is that a 90-degree angle? So I guess the question would be, let's phrase it this way. Are the lines connecting AC and CB perpendicular? That's what the question is really asking, right? Because look, we want to know if the line connecting A and C and B, we want to know if those two lines meet at a right angle, right? Okay, so how do I use the slope? So let me find the slope. So I don't know, I guess I need to, let's call this black one here. Let's call that line 1. Okay, let me look at that line for a second. Let's see what the slope of that is. So looking between the 2 points, let's see, the rise is 2. What is the run here? The run is 5 here, over to 5 here. That's 10, right? Should I double check that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the slope of that line is 2 over 10, or 1/5. Okay. So now let me look at the other line. So let's call the other one line 2. And let's look at its slope. So this one. Okay, so starting at C here and ending up at B, what is the rise? So starting at C down to B, let's see, I fall by 1, 2, 3, 4, 5 units, okay? And the X increases by 1 unit. So the slope of that guy is -5 over 1. Okay, so are they perpendicular? So the question is, are the slopes negative reciprocals? So have they been flipped, and are the signs opposite? Yes. So then my conclusion would be is it is a right triangle. So if the slopes would not have been negative reciprocals, then I would have known the lines did not meet at a right angle. And in that case, it would not be a right triangle.